I guess we'll get started. For those of you on the phone, this is Tracy, and I'm going to talk about the terrestrial fine filter conservation elements. And after our discussions yesterday, I went through and I changed my whole presentation trying to address some of the concerns. And so it's a little bit lengthy. I may skip over slides just so that, and after today's discussion, we may focus on things that I really didn't anticipate that we would focus on. I'm not advancing here.
Click on the slide.
The cursor on your presentation. There you go. Okay. So just as a review, there's 8 terrestrial fine filter conservation elements: moose, caribou, muskox, beaver, wolf, American peregrine falcon. I still can never get that one out. Trumpeter swan and olive-sided flycatcher. And I'm going to barrage you with maps from the start. I learned from Jamie the other day that you need at least 2 minutes to digest the map. So I just decided to really front load this presentation with maps, and you're going to get about 2 seconds to look at a lot of these maps. But we developed, and part of our results were to develop distribution maps for each of the specific CEs. And so we did for moose, caribou, and muskox. And what's interesting about muskox is we know that their range is just starting to extend into the northern part of the REA, so you can barely see their distribution map here, but this is where they mapped out and where we also have data to support their movement into the REA. American beaver, gray wolf, and then American peregrine falcon, trumpeter swan, and olive-sided flycatcher. So one of the questions that arose yesterday were issues of model uncertainty, and how did we handle that, or how can we address that? And so I just wanted to talk about it real quickly. For all of these species distribution models, we used existing models that came from the Elastic App Analysis project. These models were developed through a combination of inductive and deductive models, and they were statewide in scale. At the statewide scale, we used independent data to validate them. So we do have an AUC statistic associated with them, which gives us some confidence on how well the model performed or how well it predicts. And then they were also expert reviewed. So when we took these models, though, and clipped them to the REA boundary, we lost that accuracy assessment, and we can't really say anything about it. Or the former AUC value no longer pertains to this clipped section. And we didn't do a new accuracy assessment for these models. Instead, we just had them vetted by experts, and that was agreed upon by the AMT and the tech team. So that's how we moved forward. And that is about how we can really address the uncertainty with these models. I did throw up some of the gap metadata just to let you know how we suggest that the models can be used and what the applications of these models are. And I'm just going to give you a little quick overview. But these models were produced primarily as a coarse map for large areas such as a county to provide context for finer little maps. And they can be used for national, regional, such as we have here, conservation or biodiversity planning, for large area resource management planning. They can be used to determine relative amounts of management responsibility, and they can be used for environmental impact assessment for large projects. What they shouldn't be used for, however, is to establish exact boundaries for regulation or acquisition. That's the big one. And generating specific aerial measurements. So there's limitations with these distribution models. For assessing course-level patterns or course-level distribution across the REA, which is a huge area, I think that they're fine. We're okay. Okay, so these are the maps that I glossed over, or I just crammed onto one slide, but I think that will elicit some discussion. We had 3 management questions, which asked us to produce distribution models for moose. This would be willow. They wanted to know where willow was. So for caribou, lichen habitat, and for muskox, the question was there muskox habitat within the REA? Obviously, muskox are only occurring in the northern part of the REA, but is there habitat elsewhere so that they could potentially expand their range into the REA? And so Keith already talked about the development of the floodplains model. And so this is the moose habitat model that he and Monica developed. And you can see floodplain and the streams play a large role. But then they also mapped out tall and low shrubs. As part of this habitat model, And what they couldn't tease apart, again, were the willow and the alder, so the tall shrub includes both willow and the alder. So that's the result for the moose distribution map, and willing to take any discussion on anything of it.
Can you just read the legend on that one?
Yeah, sorry, so the dark blue is the floodplain, and they also categorized habitat quality as to whether it was good or moderate. So the darkest blue is the floodplain. The lighter blue, the second box down, are streams and riverbanks, and those are also considered good quality habitat. The next box down, the green one, is low shrub, and that was considered moderate quality habitat. And the next box down is red color, and that's tall shrub, open and closed, and that's also considered moderate quality habitat. Okay. The next map over, caribou. Caribou are generally associated with lichen, especially during the winter months. So they extracted any vegetation class from the land cover map for the REA that contained lichen, and then they also coded that with a quality index poor, moderate, or good. So again, the yellow is considered poor habitat, the moderate is the light green, and dark green is the highest quality habitat. And the same color configuration applies for muskox, the good habitat being the darkest green. And one of the concerns about muskox potentially expanding their range into the REA is that there could be potential competition with resources for caribou. And although we didn't really do an overlay of these two maps, you can see that in some areas the same habitats are highlighted. Okay.
So for the lichen, I think yesterday you were saying that recovery time from fire is 80 to 100 years, and the return interval of fire is expected to go down to 80 to 100 years. So did you guys look at kind of what we might expect for lichen habitat if the fire return interval and the recovery interval are pretty much the same? Does that mean we should expect a large scale loss of lichen, permanent loss of lichen over time in the REA area?
So, the fire, so remember, is well, the alfresco model particular, it's only on forested systems. So lichen, I don't know, Keith probably has a better handle on the fire, the likelihood for fire to increase in, well, maybe you don't know for the lichen classes, but the lichen classes are an amalgamation of multiple different, some of the lichen classes is a forested, does have a forested component to it, but not the majority of the things, right?
Yeah, well, I think one of the forested classes has lichen in it, the woodland spruce lichen class. And then the other classes are things like dwarf shrub and just straight lichen class. And so with the fire frequency, again, Nancy, you can jump in anytime you want here. It's just basically applying to the forested region. So we're not sure what's going to happen to fire frequency in like low shrub, dwarf shrub areas.
Well, but I should point out that what's classified as forest versus non-forest, as I said yesterday, based on alfresco, is not the same as the veg classes here. So, some of what is shrub may actually be part of that, like 90% that's being classified as forest. What was excluded were the tundra categories, which include shrub tundra, graminoid tundra, et cetera. So what you said is true, but it's a little more complicated because of the different classifications is all.
And this map in the middle, you did apply the existing fire scar map when you developed the lichen model, right?
Right, so if there was a fire that occurred after a vegetation map was developed, we basically use the fire parameter to clip the fire out of the lichen classes. So we did try to account for that.
Okay.
It doesn't seem like there's very much overlap between the caribou distribution models and the lichen locations.
may be other reasons why caribou aren't taking advantage of what these appear to be these lichen-rich areas in the middle. What we didn't have is information on historical distribution of caribou to see if they utilize these areas in the middle, and/or, I shouldn't say it, but these are probably lichen which occur in mixed forests in the center area, Keith, potentially,
Oh, yeah, probably.
and maybe those just, they're selected.
And I think there's a lot of fires up in that northern part, because that's kind of where we could be seeing a delayed response in the caribou. Responding to availability of lichen. That kind of gets at the temporal piece that we've been talking about a little bit. It's just that, these current distributions of species likely are still responding to stuff that happened 20, 30 years. So any fires that kind of happened in the last 20, 30 years ago that may have wiped out lichen habitat, they may still be responding to that. It may have looked different 30 years ago.
Well, because, a number of us went out to the communities, and for the most part, they were just, presentations, and, a good discussion with Fish and Wildlife Service when we were in Galena. But the one question I really remember from the community meeting was, in the, Iliamna area where folks came over from Mount Dalton asking, where's our caribou? How come they're not there? And it looks like they have there, to me, but they don't, so here's your TEK, but their caribou's not there, so.
What we didn't do with this map is drape it over any type of topography or look at ruggedness, and those all play important roles in whether or not caribou can move into regions as well. Other factors at play here, it does look like there is potential forage in the area.
Anyway, just, that was such a specific question that if there's any, answer to that from all of this, you might want to, when you're back out there, chat with them.
Okay, we can go on to it. Other distribution models that we created for pretty coarse scale, but were the best, based on the best available information. We mapped the distribution of caribou calving grounds. These are just these large blobs because these areas are kind of a moving target. And this is largely based on talking with biologists from each of the regional offices out throughout the REA. And then we also modeled the distribution, seasonal distribution of moose I showed you yesterday. The wintering distribution, this is their calving distribution. As you can see, it closely follows the floodplain. Uncertainty regarding these, we really don't know. This is based, like I said, on the best available information, and we work largely with experts to attain this information. So I think it's probably the best thing that we have out there for the REA. Okay, so just to talk about core analysis, real quickly, again, we showed some examples yesterday, but for each of the CEs, we overlaid their distribution with the climatic drivers, temperature, changing growing season, precipitation, permafrost and fire, and then for some of the species, such as moose and caribou, we also looked at snow day fraction to try to get a handle on icing events. And then we also overlaid the distribution with the landscape condition model to get a handle on anthropogenic impacts. And you've seen these conceptual models many times already throughout these presentations. This is just the conceptual model for the trumpeter swan. This is the results of our literature review and how we help to formulate our hypothesis on what we expect to see from these climate change effects, and to look at how all these drivers work in concert with each other. They're not happening individually or overlaid or on an individual by individual basis. So this is just an extraction, and this is an example that I showed you yesterday, so I'm going to run over it real quickly, but we projected that increases in growing season length could benefit trumpeter swans by promoting fledging success. And this is the graphic that I showed you yesterday, and we had a real good discussion, and I appreciate all the points that you brought up. But one of the questions while we were talking about this graphic was, what about the role of permafrost in trumpeter swan ecology? And so we also, based on what we found from the literature, we posited that climate change has the potential to impact swans via habitat changes linked to permafrost thaw and associated wetland drying, and that some wetlands are likely to become less suitable as they shrink and become more shallow, while other deep water may become shallower and thus more suitable. And so we overlaid the distribution for each of the CEs with permafrost, and the climate models indicated a permafrost retreat in the northern portion of the YKL study area Nancy showed this yesterday. And for the trumpeter swan, by 2060, approximately 33% of their habitat currently underlain by continuous permafrost will become discontinuous, which could have large implications. So this is just a map. The green is the distribution, the current distribution of trumpeter swans, and it's just overlain by the areas where we expect permafrost retreat, which are those yellow areas. Permafrost thaw or retreat may open up new wetland areas and increase the amount of suitable habitat for swans, particularly in the northern part of the REA. However, this comes back to those uncertainties again. Permafrost varies at finer scale resolution than captured in these maps, obviously. And areas that are shown as thawed may have frozen pockets, and areas shown as below freezing at 1 meter depth may have permanent permafrost-free zones, and this is particularly true near streams, which are also prime habitat for swans. So despite these limitations, I think the broader picture here indicates that landscape level drainage patterns are likely to change, especially in the north, which could have implications for opening up habitat for swans and other water body-related species, or other wetlands-related species. Okay, temperature, real quickly. We did this a basic overlay for the individual CEs with mean July temperature, the warmest month of the year. And in the short term, you've got some slight increases and some slight decreases, but no real obvious differences. And Nancy talked about some of the model insensitivity yesterday. But in the long term, we do see substantial warming with 97 to 100% of habitats utilized by CEs expected to see summer temperature increases of greater than 1 degree C than current averages. So there's a number of ways that this could affect the CEs. Increased potential for shrub encroachment as a result of warming and drying, increases in flooding as a result of extreme warm weather events in the spring, reduced stress during critical periods such as calving and incubation, and the one that I'm going to touch on right here are more favorable conditions for reproduction and development. So this is just an extraction from the beaver conceptual model, where we looked at the effect of increased temperature and posited that warmer weather may increase population densities, and this is based on work by Sampson and Murray and Jarema et al. But beaver densities are temperature dependent, and this is a nonlinear relationship with greatest densities occur above 4.8 degrees. Once they hit 4.8 degrees, their densities just skyrocket. And so we mapped the distribution, or this is work which was done by Nancy Fresco and Andy Floyd actually up at SNAP. The left-hand green map is the current distribution of beaver, but we looked at it, their distribution in contrast to these changing temperature or warming temperature regimes. And we used that 4.8 degree temperature as a threshold where we would anticipate seeing higher beaver densities above that 14.8 degree threshold. So under current scenarios, the yellow here indicates moderate temperatures. They're between 7.89 and 14.8%, but the darker orange color indicates what we would consider good temperature for high beaver densities, over 14.9 degrees. And you can see that over time, especially by the 2060s, increasing ambient temperatures increasing temperatures above 14.9 degrees extend throughout much of the northern part of the REA. And so we anticipate seeing higher beaver densities in the northern part of the REA, especially from a graph northward. So if we take this graphic and we just turn it into a graph, and this is the percent of current beaver distribution categorized by, this is June, July, and August temperature. I apologize, this isn't just July temperature. And we look at how their distribution thinned out. Currently, the majority of their distribution falls within this moderate temperature regime, but you see this big shift for the future, where in the long term, the majority of their distribution, or the majority of temperature under their current distribution, am I getting that right? Temperature, I should say, it's going to be in higher, or in that greater than 14.8 degrees. Sorry, I'm not articulating that well, but the take-home message here is make way for beavers, because we do anticipate that you're going to be seeing larger or higher densities of beavers based on projected temperature increases. So what does this mean for managers? You know, beavers are used as a proxy for hydrologic change and ecosystem function, and they're a major driver of change in aquatic and riparian ecosystems. And so maintaining healthy beaver populations is generally considered desirable, and a lot of the literature I read, especially came from drought-susceptible areas where they're like, introduce beavers because increases in beaver densities are considered beneficial, and beavers should be included in any adaptive management strategy. But in Alaska, we have a little bit of a different situation, and beavers are oftentimes considered pests. They're already expanding their distribution further north in response to climate-induced changes, and the associated complaints, which I was able to find, relate to flooding during spring breakup, increased giardia in the water supply, and then from folks that live out in the villages, decreased access to traditional subsistence areas because of changing water flow characteristics and streams. So, big consideration in the future if you are a manager and there are a lot of beavers on your land.
Tracy, does it actually increase giardia, or is that a concern?
I think it's just a concern because you've got,
Yeah, I'm just wondering.
if you have beavers in the area, you probably have a high likelihood of giardia. Or do they?
I don't know.
I guess I'm not getting your question like this.
Just wondering if that's just a concern people have, or is that a fact?
Oh,
That,
I think from what I was able to glean is a concern.
okay.
Okay.
It's seen it, I know, they've seen it in parts of the West.
Yeah, I mean, that's.
Right, because anytime you impound water that would normally be flowing, you have that opportunity to grow any kind of parasites or any kind of diseases and active vectors, so, yeah, it's certainly realistic.
Well, could a beaver be considered by those who don't want them there an invasive species then? Not an invasive species by the, no, by the strict sense, if they're native to that ecosystem, they wouldn't be considered invasive in that kind of management context. But they could certainly be pest species, and if they expand, or, population sizes get really large, that's obviously a concern, but.
Well, when we were doing the SMK and did the community meetings, I can tell you the folks in Cottonview were telling us they were invasive.
Yeah.
So, again, back to those people living off the land,
Yeah, if there's no record of them being in that region, then they certainly could be considered invasive.
It really just needs some actor or actress to make a fashion statement, so it's kind of.
I can probably be right.
Start making the fashion.
Yeah, it won't be such a pest then.
I know I wanted to focus my talk on some more interesting like caribou, but I think that's one of the most compelling results that we saw out of our, from our integrated products results. Okay, back to landscape condition. I showed this yesterday, and this is the same story for all the wildlife CEs, that we've got the majority of habitat is currently classified as in high landscape condition, and we don't see much change in that over time. And the only reason I wanted to show this again is I think that many of us here were at the landscape ecology meetings last week, and I never saw a slide that looked like this at the landscape ecology meetings, except during the Alaska meeting, or during the Alaska session. So we are in a unique position in Alaska where we do have intact landscapes, and we are in a position to be proactive. And so that's just my little soapbox, but the only other time you're going to see graphics like this is when Matt shows, the situation with invasive species for Alaska compared to the lower 48 as well. We are in a unique position here, so just, although we think our landscapes are degraded, comparatively we're doing quite well. Okay, so I'm going to touch on some of the management questions that got short shrift. What is the current distribution of migration corridors for caribou, and how are they likely to change in the future? So I just have this list of people here, but I wanted to shout out their names: Glenn Stout, Jim Willington, Jim Dow, Josh Pierce, Todd Rinaldi. They're all ADF&G biologists. Kyle Jolie, the National Park Service, I talked to each of them and asked them this question, and they all said, good luck answering that question. We don't have that information. Even for the Mulchatner herd, so there's a couple things. One, there's not radio collar data to support these movements for a lot of these herds. Most of these herds don't make large-scale movements except for the Mulchatner and the Western Arctic herd. And even for those herds that do make large-scale movements, they're not using the same pathways all the time. They're moving all around. So everybody pretty much was like, the best thing you can do is kind of summarize this information based on what we're telling you, based on what you can glean from management reports. And then we just added some directional arrows. So this is still, this question, this is the best that we could come up with, given the data that we had to work with. And in my defense, like, I think we really dug deep, but there's just not really data out there right now to support developing this type of map much further, except for maybe these two large herds, and that's being undertaken by multiple biologists right now to come up with this analysis. So for this REA, this is this is what we were able to achieve.
So, just out of curiosity, what these small herds that we're talking about, when we say small, what do we mean? Do you have any?
I've got it in the report, actually. I've had a table of what their actual herd size is and whether or not they're increasing or decreasing. Some herds are 200 animals, 300 animals.
So
They're not
really
very big.
small.
Yeah, these are really little, and these animals are just moving up into high areas in the summertime and down to lower areas in the wintertime. The Mulchatner herd, I'm gonna get the numbers wrong. 30,000. The Western Arctic herd is obviously the largest herd in the REA, but they're not breeding in the REA. They're just half touching in the wintertime.
So these little herds that aren't moving and appear to have no lichen whatsoever inside of their habitat area, what are they foraging on in the winter?
That's a good question.
We just don't know.
No.
Some herds don't use lichen.
Yeah,
They
they're.
use Rachel-Lanana and Ledum, and, you know, they don't all.
Other graminoids, forbs.
Yeah.
There's been reports and studies on that on the North Slope, I think, from the Western caribou herds, and it is feces, and actually took samples from them. The percentage of lichen varies dramatically. We saw that when we were up doing land cover in the western part of the NPRA. We saw quite a bit of caribou, but very few sites had any substantial lichen at all as far as our classification is concerned. But there's a lot of caribou around, so they're eating something else. And I know we focus on lichen often, but it's just a part of their diet.
Yeah.
Right, and it's the majority, or it makes the majority of their diet from the majority of their herds during the wintertime, but yeah, it's not exclusive.
So would you characterize lichen as the ice cream species, winter ice cream species for caribou, or the last resort?
Probably a little bit of both.
Yeah, it does raise an interesting question about whether or not these are vulnerable herds, or, you know, certainly taken in combination with the population estimates,
Or maybe they're less vulnerable.
or maybe they're less
potential.
vulnerable because, yeah, they're more flexible on their eating arrangements. But yeah, some interesting analogies could come out of this for sure.
And talking to Tom Paraguay about these herds, especially these McGrath area herds, he said that those were probably the most susceptible to being blinked out, because they're kind of like these island herds, you know, they go up high in the summertime on one mountain, and they come down in the wintertime, and so they are potentially the most isolated and the most vulnerable.
That's the Farewell Beaver Mountain, what's the teal color?
The teal-colored one is the Farewell Big River, and the purple one are the beaver, and the aqua-colored one are the Sunshine Mountains.
The other thing you need to know from a vegetation standpoint, in a lot of these low shrub areas, there's lichen in each of them, and all of them maybe only 5% as far as the cover is concerned, but there's lichen in each of these sites. So to say they're not foraging in a lichen area is not necessarily true. They can find lichen in most any habitat, except for probably the dense spruce, locations.
But lichen is more of a winter, more, a larger component of their winter diet than in the summer.
And you would have added snow dust too, right, if you could?
Yeah, to any of our, models for the toothed animals, so for lichen, or for the willow, or for lichen, in order to get a better understanding of the distribution, or where accessibility would be the greatest, we would have loved to have added a snow depth layer, or snow loading layer to this analysis, but it isn't available. Okay, how am I doing on time? Because there's still a fair amount of input. Okay. All right, so real quickly, we had a question, where is habitat for sensitive species that are also conservation elements? And, so all we did for this question was to overlay the distribution of the 3 BLM sensitive species that we had that were conservation elements, the peregrine falcon, the all-size flycatcher, and the trumpeter swan. And this graphic on the right is the output. Green indicates suitable habitat for 1 species. Yellow is where 2 species overlap, and 3 is where 3 species overlap. It's really hard to see. That's the red. So areas identified as suitable habitat for all 3 species are associated with riparian areas, in the central and northeastern part of the state. And it's really hard to see from this graphic. But if we graph that out, where we have overlap for 2 or 3 species, we see that they're primarily associated with white and black spruce forests, mixed white and black spruce deciduous forests, white spruce and black spruce lichen woodlands, and low shrub habitats. And this is another question where I don't know if we are really providing you with any great information. I think that this question was changed from its original form, where it's habitat for rare species that are also conservation elements. We were kind of persuaded not to include rare species in this analysis, but personally, as a rare species biologist, I think that the results could have potentially been a little bit more compelling. So, anyway, long and short story, this is the answer for the sensitive species question.
Sorry, could you either speak up or get closer to the phone, please? We can't hear you.
Yeah, I'm sorry, I'm not even sure where I'm speaking to, but.
Speaking to the ceiling.
Oh, okay, sorry about that. All right, so the next question is, what are the current types and potential impacts of diseases in ungulate populations, and how are these expected to change in the future? And this is the one question I alluded to yesterday that we weren't able to answer spatially. Instead, we did a thorough literature review for this question, and to date, what we found is that to date, there have been 19 threatening parasites that have been documented in moose and caribou populations in Alaska. The majority, or the major causes of infection include bacteria, biting flies and fly larvae, protozoa, nematodes, tapeworms, and viruses, and these are all so fun exploring this question. There's such great graphics available on the internet these days. And some of these infections are specific just to caribou or to moose, but some of them are also, shared by caribou and moose. Major impacts include decreased health and body conditions and reduced reproductive success. And reduced fitness can directly result in increased mortality rate, or indirectly as weakened animals become susceptible to predation and hunting pressures. So this is just an example on the bottom of a muscle tapeworm cyst from moose, and what I read was that if you cook this, it will be fine to eat, but don't feed the infected parts to your animals. But how can climate change affect the incidence of disease in ungulate populations? Climate change, especially warmer temperatures and increases in precipitation. With warmer temperatures and increases in precipitation, we may see range expansions and emergence of new parasites. We may see increases in prevalence and proliferation of infectious diseases. It can result in increased survivability and decreased development times for a lot of these parasites. And the diseases expected to expand northward or experience greater persistence of climate change include, that are not limited to, leptospirosis, which is a bacterial infection, winter ticks, meningeal brain worm, and liver fluke. And if you do go to this question in the technical document, there is just 6 or 5 or 6 page table of all of these infectious diseases, parasites, et cetera, that either are occurring in Alaska or have the potential to occur in Alaska. We just came off the top for this one. I wanted to answer this question because I love all these gory pictures.
Glad you're there, right before lunch.
Okay, so to summarize, temperatures are going to increase. I had Nancy say this yesterday. Her kid said, highly likely, or
Likely.
with certainty. Advantages for some of the wildlife species are reduced stress during having an incubation. Disadvantages are drying of habitat, increased spring flooding events as a result of increased melt. Growing seasons are going to get longer. Highly likely, certain, or highly likely. Advantages are advanced onset of greenup, changes in breeding season duration. Disadvantages can result in a trophic mismatch where you have animals arriving on breeding grounds that are already, they're already green, and they've missed that like peak pulse and nutrient availability. Altered precipitation regime. Advantages include changes in length and timing of snow season, particularly for the ungulates. You may have shorter snow seasons, which snow is such a limiting in their availability to access forage and just to move anywhere. Disadvantages include changes in snowpack such as depth and density. The frequency, severity, and timing of natural disturbance across the landscape. Disadvantages for wildlife include increases in rain and snow events, major winter and summer storms. I didn't really touch on fire at all, but we do anticipate increased risk of fire occurrence and severity. Advantages for wildlife include edge habitat, increased productivity of early successional vegetation, while disadvantages may include changes in forage quality and quantity. This can also be an advantage for other species. And lastly, pests and disease are likely to increase or to become more severe. Okay, I don't have time for this, so I'm just going to go back to the data gap. And these are the same data gaps that I showed you yesterday. But again, to drive home that snow depth would have been very valuable for our analysis, and was simply lacking spatial radio color data for a lot of these animals would have been great to get our hand on as well. But again, that was lacking for this REA, and that the literature just simply did not provide precise enough information regarding some of those threshold values to make linkages to the between the various CEs and the CAs. Okay. Karen?
Maybe this question is for Keith. In the report, did you make an assessment in fire and vegetation of kind of, as fire increases, the percentage of the landscape that will be in earlier successional stages at all?
We didn't do that. We applied to the lichen map, and took lichen out. Fire had occurred there. Development of the map. But for willows, we looked into doing that for the willows. We decided not to, and partly because the fire perimeters weren't all that accurate all the time. But,
I didn't really mean mapping, more just like a percentage, like with a prior return of 130 years, the percentage of landscape, like early and moderate and late successional stages are.
The shifting mosaic.
Right. What's that?
Yeah.
What's that
We don't
percentage
have
in the
that.
shifting
Yeah.
mosaic?
But we could,
Okay.
you could probably put that together, but we did not do that.
Okay. The scales are really different than.
Yeah, I mean, and as Nancy can tune in here, the alfresco model puts outputs of 0.5 or 0.75% of any given landscape being burned in any given year. So you could use that as a rough estimate of, what places within or how much of an area would be considered early successional stages, but it would be really just a rough guideline percentage-wise.
You might not.
Right. So, yeah, if you wanted to know precisely how much was burned last year, that would be hard. But if you wanted to know over a larger area what was, within the early succession rather than late succession stage, yeah, that would be an appropriate way to look at it.
Yeah. That's what I'm more generalized and over a longer time frame. How would we kind of generally expect that shift to occur?
Yeah, Nancy's presentation talked just briefly about that, and I think in the report, she highlights it too, just as the fire return interval decreases, we expect more of the landscape to be that early successional, and that's why
Yeah, and that's a pretty big take-home message from the fire modeling. Just, that even a fairly slight shortening of the fire cycle means a pretty large change in that proportion. So, yeah, I think that is a message that you can apply.
I have some tangential question. Does the REA overlap Anoka Refuge?
Yeah, in the northern.
Is there any potential for that bison reintroduction to overlap with REA? That was my question. I'm not overlapping, but what of the, and I didn't want to ask it because I know you don't focus on it in REA, but of the ungulate habitat maps, you have caribou, moose, and muskox. Would any of those be similar to the habitat for wood bison?
Probably the muskox.
Yeah,
Both similar?
the wood bison was thrown out as a possible management question at the very beginning.
Yeah.
What are the impacts of wood bison? And it was suggested as a CE even, so that we could model that potential. But then we already had 3 big ungulates, and so we'd just be, totally biasing the assessment towards these large herbivores.
So what is the habitat requirements for wood bison? What are they for?
I think they like,
Ask Keith, he's the.
well, I was just thinking, in the winter, I think they're restricted by, they like to hang out in places that were wet, the sedge meadows. And, so in winter, that's their winter habitat, so that would probably be the restricting criteria.
It's a grass that surfaces.
I think it has to be fairly dry for them. They can't go into those real wet meadow areas.
That's it. I know deep snow is a big issue for them, so
Yeah.
Yep,
some of those lowland areas can have deep snow.
something like more than 8 inches.
Like, yeah, right here.
So, I mean, I wonder about things that is this geographic area, is it gonna become more hospitable to wood bison as time goes on and temperatures warm and we have more early successional habitat?
I don't.
Yeah, it was, I didn't really know any answer, but.
Good question.
Yeah, but they like, we wanna have less snow, not more snow. I don't even know if it's been proved that they were here, across the state.
I think Anoka's not the ideal place to put them.
Are they Clyde West animals like muskox?
They're gonna land them in Shagaluk, open up the plain, and they're gonna leave from Shagaluk. So
And
that's
Shagaluk's along the coast, right? Is it?
the custom.
Oh, the coast
It's
line,
wet.
yeah.
Okay.
Did you have something to add, Karen?
Wait, which Karen?
That Karen.
Yeah.
Curious.
Well, I guess I was just thinking, because I had kind of thrown that out as a possibility at the beginning of doing that, looking at the bison range and potential expansion of it. And I think it really is a pertinent question, but at this point, it's pretty a small section of the REA. So that may have been a reason for not addressing it. But I do think that this process that was gone through for these other ungulates would be pretty worthwhile to do for that area where they're potentially being released, just to see what that habitat might look like in the future.
Where is Anoka? Is it the northern?
It's north of your map.
I guess
Right, so it's south of Caltag there when the Yukon makes that bend.
Are there any mountains?
Between Caltag and about Grayling and then to the east. And it looks like from what we've looked at, they'd probably move south from Shagaluk where they'd be released rather than north onto the refuge as much because it just gets pretty wet up there as you go north from there.
Do I remember that question?
Yeah, we discussed it a lot, and now.
Tracy, maybe, I was wondering, I know Matt and I talked about it a little bit for muskox and just that potentially maybe more, the limiting factor might be more wind or snow depth or some other characteristic maybe than the habitat mapping that we produced for muskox, just looking at where the current distribution is. That the gap model based on our kind of predictive model, there's kind of a mismatch there.
Within the write-up, there's also, Keith mentions a bunch of landforms that they're associated with, which weren't really considered in the, all we mapped, or all you guys mapped was the potential forage.
Yeah.
Right,
So
that might be, you know, the accuracy might be fairly, or I don't know if it's accuracy, but whether or not they'll necessarily move into that potential forage might.
Right, there may be any number of limiting factors which could prohibit them from being able to capitalize on that, you know, like, besides large river corridors, which they can cross in the wintertime, you know, like I said, terrain ruggedness is usually one of the metrics that we would use to try to get at that, and elevation, and those just weren't incorporated for this level of analysis, basically. We need to be really clear that all we're presenting are just available forages.
They really like bluffs in the winter, muskox do, and they also like echo trailers.
Maybe that will be a map of all the echo trailers.
Bird habitat for global species.
But Megumi, didn't you do a wood bison report? Do you
Yes,
remember what they
we
eat in
did.
winter?
Wetland sedge,
Wetland sedge, okay.
because it's frozen in winter,